This video is about finding intervals of concavity for a polynomial and points of inflection. But before we do that, what we're going to do is a little review. So we're going to do the increase and decrease of this polynomial and then relative extrema. See, the steps are the same, and so if we do this one, it's just applying the same exact steps for the concavity. So first thing we do is find our derivative. And we set it equal to 0. And so now we can factor out that 4x cubed, giving us 3x squared minus 8 equals 0. And so far we get x equals 0, but we still need to do this one as well. So our 4x cubed equals 0 gives us x equals 0. And then 3x squared minus 8 equals 0. Divide by 3. So I'm going to move over here with the answer. So x squared equals 8 thirds, square root, x equals plus or minus 2 rad 2 over radical 3. And then we rationalize plus or minus 2 radical 6 over 3. And then what I like to do is plug that in the calculator to get an approximate value for it. So we're going to pull up our calculator. And see, I already graphed it, and you'll see why we want that approximate. We're going to use the exact, of course, but 2 second square root of 6 divided by 3, enter, and it's 1.632. So this is approximately plus or minus 1.63. Is that rounded? Yes. Okay, so now we have our approximate, we have our exact. We can place these on our graph after we verify that they are correct. So we're going to plug it in our calculator, like that, and then we're going to adjust the window. And so I did a zoom 6, and then adjusted it some more for the bottom to get it in there, and we end up with this. And so now I can do trace, and then it's 2 second square root of 6, parenthesis, divided by 3, and there's 1, and so we know the other one is there, and then the other one we got was trace 0. Right there. So all three match, so we know these are correct. These are our critical numbers. So we're going to box them so I don't lose them. So we know 0's in the middle, and then we have a negative 2 radical 6 over 3, and then a positive 2 radical 6 over 3. And then now all we have to do is first derivative of each one to decide if it's increasing or decreasing, because remember, it'll increase or decrease within those intervals. So I'm just putting in a blank form here. So we have 4 intervals, positive or negatives as we go across. So negative 100 works there. And this is why we do an estimate. It's 1.63. It also tells us that as well here. So trace 2 second square root of 6, parenthesis, divided by 3. And you can see it also gives that 1.63 that we're talking about here. But knowing that that's negative 1.63, something between here and here would be negative 1. And then that would be 1, and then we can do 100. And if you remember correctly, we always use our factored form. So this one right here is the 4. We don't have to worry about it. We're just looking at x cubed, and we're looking at this, and we're deciding if it's positive or negative. So if I plug in a negative 100 into the x cubed, that would become negative. And if I plug in negative 100 in here, that would turn positive. And so that would be really, really big. So it would be positive. And that gives us a negative. So we know our function is negative. It's decreasing. We go back to our graph and we go, yes, it's decreasing. In fact, we can now see that it's increasing, decreasing, increasing. So we know it's going to be positive, increase, negative, decrease, positive, increase, and so we just need to make sure that's true when we go through here. So if I plug a negative in here, it would be negative. If I plug a 1 in here, that would be 1, and 3 minus 8 is also negative. So negative times a negative is a positive. Checks perfectly. And then we do the same thing with 1. That would be positive and negative. And so that would be negative, checks. And then 100 is big. It's the same thing as over here. This is positive. That's a massively big positive. And so it's positive, it checks. So we're increasing from negative 2 rad 6 comma 3 to 0, and from 2 rad 6 comma 3 to infinity. And it's decreasing from negative infinity to negative 2 rad 6 over 3, union 0 to 2 rad 6 over 3. Now the reason we already knew how to do this, it's just nice to have another example, but why are we doing this before we find intervals of concavity? The same steps we did here are the exact same steps we're going to do there. And so in order to determine if it is a minimum, it has to have decrease, increase. It has to have this shape. So we know that we have a min, a relative min, of, and then now we can take our calculator and plug it in. So 2 rad 6 gives us a negative 11.96. At negative 2 rad 6 comma 3 and at 2 rad 6 comma 3. Those were our mins. And then we also have a relative max of, and then we can go back and use trace 0, and it says 7 at 0. So by doing this, we know that if we have a change from increase to decrease, or decrease to increase, then we're going to have a relative extrema. And if it's a change from negative to positive, we know it's a minimum. And if it's positive to negative, we know it's a maximum. But we get our relative extrema when there is a change in intervals from increase to decrease or decrease to increase. Well, that's going to be the same thing for our points of inflection when we get changes in concavity. So now, if we take our first derivative, I'm going to rewrite it. We take the second derivative and do exactly the same steps, which means set it equal to 0, find those numbers. Those numbers are now possible points of inflection. Plug in the same values, and instead of increase, decrease, it will change to concavity. See, these are intervals of increase, decrease, and so it's giving us increase and decrease, and these will give us intervals of concavity, just like the video before. Second derivative is positive, then we get concave up, and second derivative is negative, we get concave down. So let's find our second derivative. This would become 60 x to the fourth minus 96 x squared. Set it equal to 0. And we factor out that 12 x squared, which would be 5x squared minus 8 equals 0. And then again, 12x squared equals 0 means x is 0. And then 5x squared minus 8 equals 0. See how it's the same basic stuff? So x equals plus or minus 2 rad 2 over 5, rad 5, times rad 5 times rad 5. So it's plus or minus 2 radical 10 over 5. And then we put it on our graph. So negative 2 rad 10 over 5, 0, and 2 rad 10 over 5. So now when we plug in those points, and we should check them anyways, so trace, and then 2 second square root of 10. Remember, we're always using the original function because it's the one that we're asking questions about. Divided by 5. You see it plops right there. That is where you can see that we have our concave down, and then from there it's concave up. That's a point of inflection. So let's put all this on the graph. So now we're going to do second derivative of a number over here, so like negative 100. The decimal form of that is 1.26, so that would be negative 1.26 and positive 1.26. So we could do f prime, double prime of negative 1, f double prime of 1, and f double prime of 100. Now, what it's asking here when you do these is concavity. So from that point, you can see this is concave up, right over here. So this is concave up. And then from 0 to that point, you can see that it's concave down. It looks like this. And then from 0 to the other point, which would be just a mirror image over here, it's also concave down. And then following from that point on is concave up. So this means that our second derivative is going to come out to be positive because it's concave up. It will come out to be negative because it's concave down. And our second derivative will be concave up because it is positive. Again, our derivative here is increasing, our derivative is decreasing, and our derivative is decreasing, and our derivative is increasing. So let's plug them in and see it. Here's a nice thing with squares, is if it's square, you don't have to worry about it. The 12 and the x squared will always be positive. So we're just looking at the inside. So if I were to plug a negative 100 in there and square it, this would be massively positive. And there you go. You can see that it is positive, concave up. Now we look at the negative, that would be 5 take away 8. That comes out to be negative. And so again, come on red, concave down. And then I do the same thing here. If I plug in 1, it would be the same thing, which is negative. So again, concave down. And then the last one, if I plug 100 into 5x squared, that would be really massively positive. So again, concave up. So now we want intervals of concavity. We would say it's concave up on the interval negative infinity to negative 2 rad 10 over 5 union 2 rad 10 over 5 to infinity. And it's concave down from negative 2 rad 10 over 5 to 2 rad 10 over 5. It doesn't stop its concavity at 0. It is literally negative from here to here. You can see that our concavity goes from here all the way up and then back down. That is a full concave down. So even though we're getting 0 here, right, that just means that the second derivative is 0. But our slope is still changing as we go from here to here. See, it's just becoming positive, right? And then now it's negative. Our slope is still, of our tangent is still decreasing. Our first derivative is still decreasing all the way around. So we have to list the whole thing. You do not put 0 in there as a split. It did not split. Where it does happen is that is now not a point of inflection. So points of inflection have to have a change in concavity. So we're going to change from concave up to concave down, or concave down to concave up. So it went from positive to negative, concave up to concave down, at negative 2 rad 10 over 5, which means that is a point of inflection. It also changed concavity from negative to positive here, so this would also be a point of inflection. And all it is we're looking at our graph, and our graph does this, right? And let's put it in actual form and color. It did this, and then it did this, and then it did this. So this is our second derivative is positive. And this is our second derivative is negative. And these points here, since we have a change in concavity from concave up to concave down, these are points of inflection. Okay, so now we just need to make sure we label them as points. So if we pull up our calculator, I already plugged it in as negative 5.288. And I guarantee the other side is the same, but we should verify it. So trace, and then negative 2 second square root of 10 divided by 5, and hit enter. And there it is, negative 5.288, same thing. So those are points of inflection. So you can see it's the same steps. Once you understand what we're doing for intervals of increase and decrease, for concavity and points of inflection, it's the same thing. That's a relative extrema because we have a change from negative to positive. That is a relative extrema because we have a change from positive to negative, and so on. This is a continuous function, so we don't have to worry about them being undefined values. Same thing here then. If you have a change in concavity, so that would not be a point of inflection. Just those two are, because those are a change in concavity. So whatever we did here, we're just doing it again with the second derivative. Thank you.